In August 2026, the Bote-Koshi River Valley in Nepal went unnervingly quiet. Miles upstream, deep within Tibet, an invisible crisis had already taken shape. A massive collapse of glacier ice and rock had choked the river, piling up to create a highly unstable temporary dam. The collapsing blockage released a viscous gray wall of earth and rock that surged downstream with the crushing weight of a mud tsunami. By the time the surge settled, at least 270 people were dead, leaving several hundred more missing in the debris. Yet this valley sits in a country that has spent decades installing advanced early warning systems. How were so many people caught entirely off guard? Over the past 20 years, Nepal has poured resources into protecting its citizens from seasonal floods. They have actively monitored vulnerable watersheds with modern technology, but those sensors only monitor what happens inside the country. The Bote-Koshi landslide started in Tibet, well outside of Nepal's jurisdiction and blind to its domestic sensors. As the physical debris slammed into Nepal, the critical digital data signals hit a wall. There was no real-time data exchange passed across the international border. Without a direct, immediate link between upstream sensors and downstream alert networks, millions of dollars in life-saving technology become effectively useless. Natural hazards do not carry passports. The mountains operate as a single ecological system, yet the data required to survive it remains trapped within political lines. To understand the gravity of this data gap, we have to look at the immense effort Nepal undertook to build its current system. Just 2 decades ago, flood preparedness relied on physical endurance. Local volunteers would sit in raised bamboo watchtowers through the monsoon nights, watching the water levels and shouting through megaphones to wake up nearby settlements. That gave families a small window to run. But today's high-altitude landslides and glacial surges move far too fast for manual observation to work. In response, Nepal built a multi-hazard early warning system. They replaced volunteers with automated weather stations, real-time river-level sensors, and digital community sirens connected to regional forecasting centers. They even engaged in massive engineering feats. At Imja Glacial Lake, crews manually constructed drainage channels to lower millions of cubic feet of glacial water by over 10 feet, physically neutralizing the threat to downstream villages. Nepal has done the grueling, expensive work of modernizing its domestic survival tools. That makes the failure to receive upstream data a critical vulnerability. A functional early warning system relies on an unbroken chain of 4 pillars: risk knowledge, monitoring, dissemination, and response. At the local level, the dissemination and response links are strong. Downstream communities receive digital alerts and run regular evacuation drills. But look at the monitoring link. When a hazard originates in a neighboring country, this chain snaps. To give people enough time to evacuate, seismic sensors and water gauges have to trigger an alert at the exact origin point of a mountain collapse. A fully modern domestic warning network is effectively blind if it cannot monitor the origins of its major rivers across the border. This vulnerability is expanding as global temperatures rise, placing immense physical stress on the Himalayan ecosystem. Permafrost, the frozen soil that glues these mountains together, is thawing. As it melts, the slopes destabilize, resulting in more frequent and massive rock avalanches. At the same time, melting glaciers collapse into high-altitude lakes. If the natural dams holding these swollen lakes fail, they trigger sudden, unstoppable surges of water and debris, events known as glacial lake outburst floods. Climate change is actively compressing our margin of error. Every single minute of early warning has become a rigid boundary between survival and disaster. The geopolitical realities between Himalayan nations like India, China, and Nepal are deeply complex, but the physical vulnerability to these collapsing slopes is entirely shared. We already have the scaffolding for a solution. Initiatives like the World Meteorological Organization's South Asia Hydromet Forum actively connect the region's scientific agencies. These regional platforms need to be scaled up immediately to bypass political friction, enabling direct, real-time sharing of upstream sensor data and forecasting expertise. Ultimately, technology can only buy us time. To survive the rapid changes in the Himalayas, nations must tear down their walls of data secrecy before the next surge of mud and ice washes down the valley.